Hey guys, Professor Doney back. We're continuing to talk about circuits, and this time we want to continue our last problem, which was finding the current, total current, and the power that this circuit needs or requires. We found that in the last video, so check that out. Today we're going to do cost to operate. We're going to run this for an hour a day for 30 days, and we want to find out how much it costs. Now, if you look at your electric bill, what the power company charges is not for current, but for energy. All right, power is energy over time. So if we rearrange that, we get energy is power times time. So what they charge you for is kilowatts hour. Okay, so if you look on your electric bill, somewhere you'll be able to see that, okay, they charge us 12 cents per kilowatt hour. That changes usually depending on the time of day, the time of year. You know, if it's a high load time when everybody turns on their air conditioners or kicks in the heat, and they make some good money. So let's say we're charged 12 cents an hour and we want to find out. So what we're going to do is take those watts, the power, and we have to multiply it by that change, that time. We want to get kilowatt hours. So we're going to have 500 watts, and what we're going to do is change that to kilowatts. So we divide it by 1,000 or move it over 3 decimal places so we can be in the kilowatt range. That is times the 0.12 kilowatts per hour, right? Because that's in pennies. We want to keep this in dollars. We multiply it by 1 hour a day, DAY, and we're going to do 30 days. Okay, so if we go through and multiply that through, multiply through, the kilowatts drop out, the hours drop out, and the days drop out. So if we're able to find a calculator here and take 0.5 times 0.12 times 30, we'd find out it would cost us basically $1.80 to run that for a full month. Okay, now half a kilowatt or 500 watts is not a big deal. If you look on your hair dryer, it's probably a 1200, 1800, even 2000 watt. Okay, but what I'm going to do here is just change the problem up a little since we have some time. Let's say this device, we had a second one built here. Okay, this one required, we saw 500 watts. All right, what if we had another device plugged in parallel, so we have two powers, and this one cost or ran 1500 watts, right? And you look on heaters, things like that, they talk about wattage, and that obviously takes more electricity. But let's say we change the problem up and we have both of those. How do we find out the cost to run both of them? Well, that's going to change. It's no longer going to be the 500. We add those two together, so the total here is 2,000 watts, and that equals 2 kilowatts. So this number here becomes a 2 all the way through. All right, 2 all the way through. So if we go 2 times 0.12 times 30, it gives us $7.20. Now that's for both of them for a month. We could also see that our power increased from 500 to 2,000, or by a factor of 4 times. So we'd expect our cost to also go up by 4 times, which it does. So there's a quick one on finding the cost to operate and dealing with powers when we have them like that in parallel. And we're going to talk about series and parallel next. The nice thing about parallel is if this one gets turned off or blows out or no longer working, the current can still get and run the other one, which is the way the house should be set up, so that if one thing goes down, it doesn't take down the whole circuit. So hope that worked for you. Gave you a little practice on finding the cost to operate these devices or circuits, and we'll see you next video.